Hello, in this video we will cover section 1.7 and 1.8. Section 1.7 is titled Problem Solving Using Conversion Factors. And so this is an important topic here, as you will need to be able to do this kind of calculations all quarter long. This is also sometimes called dimensional analysis. But basically, it's you will learn how to solve problems by using conversion factors. And in this section, we will practice with simple unit conversions. But the principle of how you set up your calculation is one that chemists use whenever they do stoichiometry. And so it will be used a lot in this quarter. So you need to use this chapter to practice the process so that you are ready when it will be more chemistry-like. So we will use conversion factors. A conversion factor is a term that converts a quantity in one unit to a quantity in another unit, right? In conversion, there is convert, and so we will convert a measurement in original unit, and by multiplying by that conversion factor, the only thing we do to the measurement is changing the unit in which it is expressed. It does not change the measurement value per se, but it changes the expression into another unit. But it's the same quantity expressed in a different unit. So conversion factors typically come from equalities. Conversion factors are written from equalities. So we always start with an equality. For example, 2.20 pounds equals 1 kilogram. That's an equality because there is an equal sign here between two statements. And so let's say now we want to divide both sides of this equality by 1 kilogram. So if we divide the left side by 1 kilogram, we will get 2.20 pounds over 1 kilogram on the left. And on the right side of the equal sign, we will have 1 kilogram over 1 kilogram. 1 kilogram over 1 kilogram, because it's the same thing on the numerator and on the denominator, it is equal to 1. So that means 2.20 pounds over 1 kilogram is equal to 1. And so that's one of the conversion factors. We write them as fractions. And so the first conversion factor that we can write from this equality is this one, 2.20 pounds over 1 kilogram. And so you can see here, because we demonstrated that this is equal to 1, when you're multiplying your original quantity by a conversion factor, it's equivalent to multiplying by 1. So it really only changes the unit, and it's not changing the measurement otherwise. Now let's go back to our equality, and if this time we are dividing both sides of the equality by 2.20 pounds, so on the left we will have 2.20 pounds over 2.20 pounds, and this will be equal to 1. And on the right we will have 1 kilogram over 2.20 pounds, and this will be equal to 1 as well. And so that's the second conversion factor that you can write from this equality. So from an equality, there is always two conversion factors possible. And so you will have to determine which one you need to use. So know that mathematically, if a unit appears in the numerator in one term, the denominator and in the denominator in another term, the units cancel, right? Just like earlier we did 1 kilogram over 1 kilogram, it was equal to 1 because everything was canceling, because we had the same thing on top and on the bottom of the fraction. So we can do this kind of canceling with units. And that's the driving force for this type of problem solving. So the goal in setting up a problem is to make sure that all unwanted units cancel and that you end up with the desired unit only at the end. So let's look at an example. If we want to convert 130 pounds into kilograms, so our desired unit is kilograms, and our given unit, the starting unit, is pound. So we will need to find a conversion factor that converts pound into kilograms. And so if you find an equality that relates pounds to kilograms, then you will need only that one conversion factor to change 130 pounds into kilograms. So if you look at the table where you have your common equalities between the metric system, the English system, and between the English and metric system, you need to look here because kilogram is a metric system unit, pound is an English system unit. So you would look for metric to US conversions, and pound and kilogram are units of mass. So you would look for mass. So mass and then metric to US. And in there, we know 1 kilogram is equal to 2.20 pounds. And we know already that there are two conversion factors from that equality. And so now the trick is to find which one of these two conversion factors we should use. So you need to look at the starting unit, and you always start your calculation by having the given amount written first. So here it's 130 pounds. And you want to cancel the pound, so that you want to cancel the pound and you want to have the desired unit of kilograms not being cancelled. So you will want to choose the bottom conversion factors in this example because it has the unit you want to cancel in the denominator. And you always cancel from the numerator to the next denominator. So here pound from the given amount will be cancelling with pound from 1 kilograms over 2.20 pound. And so if you do calculate that in your calculator, it comes down to do 130 divided by 2.20, and that's equal to 59 kilograms. So here, notice here we keep two significant figures because 130 pound has two significant figures. That 0 is not significant. And 2.20 pound also has two significant figures. No, sorry, three significant figures, sorry. The 0 in 2.20 pound is significant because we see the decimal point, okay? So this is not limiting. And 1 kilogram is an exact number in this definition. So we keep two sig figs. Typically, the number of sig figs is limited by the given measurement. Often that's the case. So the unwanted units of pound cancelled and the desired unit of kilogram stayed in the numerator, and that's then the unit of the final answer. Let's go over an example in detail to help you practice that. So how to solve a problem using conversion factors. Example, how many grams of aspirin are in a 325 milligram tablet? The first step is to identify the original quantity and the desired quantity, including their units. So here, how many grams of aspirin are in a 325 milligram tablet? So the only measurement given here is the 325 milligram. So that will be the original quantity, what you will start with. The question is asking for how many grams there is in that tablet. So how many grams? It's the desired quantity. We want this 325 milligram into grams. The next step is to write the conversion factor needed to solve that problem. And so we saw that we have milligrams and we want grams. So you want to find the equality between grams and milligrams. And grams and milligrams are a metric system unit. So when you have this kind of units to convert, you want to use the metric prefixes. So you want to use the table that has the metric prefixes. And the milligram, so the milli prefix is 0.001, it's the value. As I told you, when you have 1 milligram equals 0.001 gram, you can also rewrite this by multiplying by 1,000 on both sides. And so 1 milligram becomes 1,000 milligram, and 0.001 gram becomes 1 gram when you multiply by 1,000. So this equality is written like this: 1 gram equals 1,000 milligram. So out of this equality, there are two possible fractions, two possible conversion factors, depending on if you are dividing both sides of the equality by a gram or by 1,000 milligrams. So we need to decide out of these two conversion factors which one we will use to convert our 325 milligrams into grams. And so because we start with milligrams, we want to cancel milligrams. So you want to choose the conversion factor that has the milligrams on the bottom, so that they will cancel with the given milligrams. So the 325 milligrams, the milligrams will cancel with the 1,000 milligrams. And so then the next step is to set up the calculation and solve the problem. So you always start your calculations by writing down the given measurement. And here the given measurement was 325 milligrams times. And then you want to use the conversion factor that will cancel the milligrams. So you will write your 1 gram over 1,000 milligrams. And so it's multiplied, right? You multiply the given measurement by the conversion factor. Remember that multiplying by a conversion factor, it's like multiplying by 1. So it's still the same measurement, but it will be expressed in a different unit in the end. In your calculator, you do 325 divided by 1,000, and that will be 0.325 grams. The milligrams cancel. So for sig figs, the given amount, of course, is a measurement, so it has uncertainty, and here it's 3 significant figures, the 3, 2, and 5. So the conversion factors that come from the metric system are all exact numbers. The 1 gram is an exact number. The 1,000 milligrams are exact numbers. The metric system established their equalities such that it's exactly that 1 gram exactly equals 1,000 milligram. So these numbers will never be limiting your number of significant figures. They are considered exact numbers because they have been established by definition to be exact numbers. So they will not limit your number of sig figs. So the number of sig figs for the final answer depends on the number of sig figs in the given measurement. And here we will keep 3 sig figs, and the 0, the 0.0 or the 0.325 here, that 0 is not significant. So we keep the 325 and the unit is the gram. So always pay attention to write your final answer with the correct number of significant figures. So let's practice. We will practice with two simple problems. You want to practice on your own before you watch the answer. It is important that you try this by yourself before watching the answer. So convert 7.8 kilograms to miles. So here the given amount is 7.8 kilograms. What we need is miles. It's asking to convert this to miles. So we want to find how many miles that corresponds to. So we will need to find an equality that will connect the kilograms to miles. And so for this, you will need to look at the table that gives the common equalities between metric and the US system, because kilograms is a metric system unit and miles are an English system unit. So you need to look at this column, metrics to US, and then kilometers and miles are units of length. So you want to look for length, and then metric to US. And here you should find that 1 kilometer is equal to 0.6214 miles. This can be written in another way. Sometimes it's 1.6 or so mile. No, sorry. It could be written as 1 mile equals 1.6 kilometers, probably with more sig figs than that. But the one I have in the table I provided in the reference for unit 1 is this one. The 1 kilogram equals 0.6214 miles. So out of this equality between kilometers and miles, we can write two conversion factors. So we need to find the conversion factor that we will use here. And the way to know this is looking at the given unit. The given unit is kilometers. So you want to cancel kilometers in the denominator of the conversion factor. So the kilometers will have to be in the denominator. So you will need to use the conversion factor that has the miles on top and the kilometer on the bottom, because then the kilometers from the given amount will cancel with the kilometer from the conversion factor. So now if we write our calculation, it's 7.8 kilometers times 0.6214 miles over 1 kilogram, kilometer. The kilometers cancel and we are left with miles. And now in the calculator, we do 7.8 times 0.6214 and 4.8462692 miles is the calculator answer. Right? Remember that your calculator doesn't know about sig figs, so you need to remember to round this properly to the correct number of significant figures. The 1 kilometer is an exact number there. The 0.6214 mile are measured, because between the English and the US system, we had to do some measurements. The one was made exact, the 1 kilometer, but then the miles were calculated, were measured. But this number in miles has 4 significant figures, right? The 0 is not significant, but then the 6, the 2, the 1, and the 4 are significant. Then the given amount has 2 sig figs, 7 and 8. So it's the limiting number of significant figures. Remember that when you are multiplying and dividing, The rule is to keep the least number of significant figures. So 7.8 is the least number of sig figs, 2 sig figs. So rounding 4.84692 into 2 sig figs will mean that you keep the 4 and then the 8. That's 2 sig figs. What comes after the 8 is a 4. It's below 5, so you will need to round down, which means you keep the 8 and you drop everything that comes after. So this rounds to 4.8 miles. So that's the answer to this problem. Let's practice with another problem that is asking to convert 30.0 grams to ounces. Again, you want to be pausing the video to practice this before you watch. So the given amount here is 30.0 grams. And we need, the question is asking to convert this to ounces. The symbol for ounces is OZ. It's an English system unit. So we'll need to find an equality that relates ounces to grams. Ounces and grams here are units of mass. So be careful, ounces here are not fluid ounces. So it's a unit of mass, not a unit of volume. So we will look for mass, and in the table you look at the rows of mass, and then you look for the column where you have metric to US conversions. Metric to US because grams are metric and ounces are English. And in there I can see 28.35 grams equals 1 ounce. So that's the one you will want to use that relates directly grams to ounces. So out of this equality, there is two conversion factors possible. So you need to decide how to write your conversion factors for this problem. The given amount is in grams. So you want to cancel grams. So you will use your conversion factor such that the grams are on the bottom and the ounce will be on top. So starting from grams, you will want to use the conversion factor with 1 ounce on the top and 28.35 grams on the bottom. And now if we write down our calculation, we always start with the given amount. So 30.0 grams times you multiply by the conversion factor. Notice how on computers, the 30 grams here are like aligned with the fraction line here, but really the 30 grams are in the numerator. It's very important you realize that this given amount is written in the numerator. And so you could draw a line under and put a 1 in the denominator to remind yourself that the 30 grams here is in the numerator. So we have grams in the numerator and grams in the denominator, so they will cancel. We are left with ounces. When you want to calculate this in your calculator, you do 30 divided by 28.35, and that's the calculator answer written there. So we will need to pay attention to significant figures. So 30.0, how many significant figures in there? It's 3 significant figures, right? The 2 zeros are significant because you see the decimal point. So it's 3 significant figures in the given amount. The 1 ounce is an exact number. The number of grams is measured, but 28.35 has 4 sig figs. So the limiting number of sig figs is from the given amount, and it's the 30 with 3 significant figures. So we need to keep 3 significant figures. So for the final answer, we will keep the 1.05. So that's going to be 3 sig figs. What comes after the 5 is an 8. it's above 5, so you will need to round up. So 5 rounded up will become a 6, and then you drop everything after that. So the final answer is 1.06 ounces. So notice here we used conversion factors or equalities that we found in the tables provided that provides those equalities between units because they are common units. But sometimes equalities will be stated in the problem, within the problem, and they will apply only to that problem. So you have to make sure you understand what the text is telling you and extract the information from the text. It's an important skill to have. And for example, in a text, you can see something like that. One tablet contains 500 milligrams of vitamin C. There is no equality written there, but you should read this as an equality because it tells you that one tablet, that's you know, a quantity, contains, you can change that into equals 500 milligrams of vitamin C. And there you go, you have an equality. One tablet equals 500 milligrams of vitamin C. So it's important to recognize these kind of sentences as, you know, giving you an equality. So out of this equality, as always, you can write two conversion factors. So either 500 milligrams of vitamin C over one tablet, or one tablet over 500 milligrams of vitamin C. As far as significant figures, here the tablet is something that you know, one tablet, it's a number of obtained from counting a number of tablets. So that's an exact number. Remember that exact numbers are numbers that can come from counting. And the 500 milligrams, however, is measured. It's in a laboratory where they manufacture those tablets. They would measure 500 milligrams or so. And so the way it is written here, there is only one significant figure. It's the 5. Those two zeros are not significant because there is no decimal point that is shown there, right? If there was a decimal point, then we would have 3 significant figures. But because we don't have a decimal point shown, then it's only one significant figure. So most of the time you need more than one conversion factor. Sometimes you need 2 or more conversion factors. And so the key to know how to string them is to always arrange the conversion factors such that the denominator in one term cancels with the numerator in the preceding term, right? It's the key to guide you and help you write the setup. Let's go through an example to illustrate that. So how many liters are in 1.0 pint? Okay, liters to pint, or pint to liters rather. Pint is a metric is an English system unit, the pint. The liters are the metric base unit for volume. So these two units are units of volume. So you will want to look at the rows where you have conversions for volumes. And then you will want to look at metric to US, right? And metric to US, we have 1 liter equal 1.057 quart. So that can be used to change liters to quarts, but here we're starting with pint. And so if you look at English system units only, there is a relationship between the quarts and the pint. 1 quart equals 2 pint. So that's what you will want to use to change the pint into quarts, and then you can change the quarts into liters. So you will need those two equalities. Oh, yeah, let me show that we had the original quantity was 1 pint. The liters are the desired quantity. And so we need two conversion factors. We determined that we will need 2 pints equals 1 quart to change the pint into quart, and then 1.06 quarts equals 1 liter to change the quarts into liter. So from the first equality, 2 pints equal 1 quart, we need to decide out of the two conversion factors, which one we will need to use. Because the original quantity is in pint, you want to cancel the pint in the conversion factor. So you want the pint in the bottom of the conversion factor. So that means you will use the second conversion factor that says 1 quart over 2 pint. Right? Choose the right side to cancel pint. Then when you have multiplied your original quantity by this first conversion factor, you will multiply by another conversion factor that will change the quart into liters. And so to decide out of the two conversion factors that come from the equality between quarts and liters, you need to cancel the intermediate unit that you have in the conversion factor. Because the pint have been cancelled, now you have the quart here as an intermediate unit that you want to cancel. So the second conversion factors will need to have quart in the denominator so that we can cancel the quart in the first conversion factor. So you will choose again the conversion factor on the right side so that we can cancel quarts. And then you will be left with liters on the numerator, which is the desired unit. So that's what you want. So if we write the calculation and set up the problem, you always start your calculation by writing down the given amount. Remember here that the given amount is in the numerator. So you could write a line under and a 1 in the denominator to remind yourself the 1 pint here is in the numerator. You multiply by the first conversion factor. So we determine that the first conversion factor is 1 quart over 2 pint, such that the pints will cancel. The second conversion factor that you multiply the rest with needs to cancel the quart. The quart here on the first conversion factor is an intermediate unit that you don't want to keep. So you will want to cancel it in the next step. So quarts on the numerator and quarts in the denominator of the second conversion factor will cancel. And you will be left with liters, which is the desired unit, which is what you want. So in the calculator, you do 1 times 1 times 1 divided by 2 and divided again by 1.06. If you do not get this value, this calculator answer of 0.471698113 liters, make sure you divide 1 by 2 and then divide again by 1.06. Another way to type this in your calculator is by doing 1 divided, open the parentheses, 2 times 1.06, close the parentheses. By using the parentheses in the denominator, you let your calculator know that this multiplication of 2 times 1.06 must be done before it is used to divide the numerator. So now, sig figs. So the 1 quart over 2 pint, these are exact numbers by definition in the English system. 1 quart equals 2 pint exactly. Between the quart and the liters, the 1 liter here is exact, and then the 1.06 quart is measured. You had to measure that between the liter and the quart. But here it has 3 sig figs, the 1, the 0, and the 6, 3 sig figs. And finally, the given amount is 1.0. In 1.0, there is 2 sig figs, the 1 and the 0. The 0 is significant here because we see the decimal point. So here we have 2 sig figs in the 1 pint and 3 in 1.06 quart. So the limiting number of significant figures comes from the measurement itself, the pint, and it's 2. So we need to keep 2 sig figs. So in the final answer, starting from the 0 is not significant. Then we start counting with the 4, 1 sig fig, and then 7, 2 sig figs. What comes after the 7 is a 1. So that means we will round down and we will keep the 7 and drop everything that comes after. So the final answer will be 0.47 liters. And so that's how we convert 1 pint to 2 liters. Let's do some practice now. Let's do the first practice problem. An Italian recipe for making creamy pasta sauce calls for 0.75 liters of cream. Your measuring cup measures only in cups. So how many cups should you use? So again, before you watch for the answer, please try this problem on your own. So pause the video. So what is the given amount here? The given amount is 0.75 liters because there is no other measurement stated there. So you know it's that. The question is asking for how many cups. So we want to know how many cups we have, we need when we want 0.75 liters. So we will need to connect liters to cup. So liters are a metric system unit. Cups are an English system unit. So, and both are units of volume, right? So you will look into the rows where you have the equalities for volume. And then you will look for metric to US conversions. And here we can use the same as earlier, the 1 liter equals 1.06 or 1.057 quarts. So that would change the liters into quarts. And quarts is an English system unit. So now let's look at the US to US conversions. And so let's try to see if there is a quart to cup. And yes, we have 1 quart equals 4 cup. So we can use those two conversion equalities. 1 liter equals 1.057 quart, and 1 quart equals 4 cups. So before you decide on the conversion factors, I like to use what I call a roadmap that shows the units you start with, the intermediate unit you have to go through, and then the final unit you want to have. And that will help you write down the conversion factors. So here we have, for given, we have the liters. We need cup at the end, but we saw that there is no liters to cup direct relationship. So we have to go through quarts. So we will then go from liters to quarts and then from quarts to cup. So for the first conversion from liters to quarts, we will use the equality that has 1 liter equals 1.057 quart. So to decide which way you will write your conversion factors, you remember that you start with liters, and so you want to cancel liters. So you will want to write the 1 liter in the denominator of your conversion factor such that the liters will cancel. So you will use this first equality like this. The quart on top, the 1 liter on the bottom, so that the liters cancel. The next conversion factor needs to cancel the quarts because the quarts are an intermediate unit that we do not want to keep. So we need to write 1 quart equals 4 cups such that the quarts will be cancelled in the denominator, because in the previous conversion factor it's in the numerator. So then you will write 4 cups over 1 quart because then the quarts can be cancelled. And you will be left with cups in the numerator, and that's the desired unit, so it works. So write down your setup by writing first your given amount. Always start with the given amount. So here, 0.75 liters. As a reminder, this is in the numerator, so you could draw a line under and have a 1 in the denominator to remind you this is in the numerator. You multiply by the first conversion factor with the quarts on top, the liters on the bottom, and multiply again by the second conversion factor with the cups on top and the quarts on the bottom. We verify that it's properly written by cancelling units. The liters cancel and the quarts cancel, and we're left with cups, which is what we want. So now in the calculator, you will type 0.75 times 1.057 times 4. Here, the denominators are all 1, so you can ignore that because dividing by 1 is going to give you the same answer. So the calculator answer is 3.171 cups. So now we need to look at significant figures. Let's start with the 4 cups equals 1 quart. This is by definition in the English system. It is established that 1 quart is 4 cups exactly. So these two are exact numbers. The 1 liter and the quarts there, the 1 liter is exact, but the quarts here were measured. And in 1.057, we have 4 sig figs. And finally, in the given amount, 0.75, we have 2 sig figs, right? The 0 is not significant, then the 7 and the 5 are significant. So 2 sig figs in the given amount versus 4 in the quarts. So again, the limiting number of sig figs comes from the given amount, and it's 2. So the final answer should be, so you keep the 3 point, and you keep the 1, that's 2 sig figs. What comes after the 1 is a 7. It's above 5, so you will need to round up. So the 1 will be rounded up to a 2, and then everything after that will be dropped. So the final answer will be 3.2 cups. Let's practice some more with another problem. Again, it is important that you try this on your own and that you pause the video before watching the answer. So a doctor advises you to take 2 grams of vitamin C per day. How many tablets of 500 milligrams each should you take per day? So the given amount here is 2 grams of vitamin C per day, right? 2 grams of vitamin C. It's not the 500 milligrams, right? Because how many tablets of 500 milligrams each? These tablets of 500 milligrams each, you should see that this is a conversion factor. So it's not your given amount, it's something you will use to convert tablets to milligrams or milligrams to tablet. So next, what do we need? What is the question asking? Well, it's asking for how many tablets. So it's really tablets that you're looking for, tablets of 500 milligrams each. So to connect here, we will need to, so because we start with grams of vitamin C, and the tablets are made of 500 milligrams, so you will want first to change the grams into milligrams. Both grams and milligrams are a metric system unit, so you will need to look at your table of prefixes for the metric system. And we know that 1 milligram is 0.001 gram. But I like to multiply this equality by 1,000 and say that 1,000 milligram equals 1 gram. The other equality comes from the fact that one tablet contains 500 milligrams of vitamin C, right? It says tablets of 500 milligrams each. That's how you want to read this. It's an equality that says one tablet equals 500 milligrams of vitamin C. So this way, with those two equalities, we should be able to change our grams into milligrams of vitamin C and milligrams of vitamin C to tablet. So the roadmap looks like this. Starting from grams of vitamin C, we will change that to milligrams of vitamin C, and then that to tablets. So the first conversion factor should change the grams into milligrams. So we will need to cancel grams because the starting amount is in grams. So the 1 gram will be written in the denominator so that we cancel with the starting unit. And the 1,000 milligrams will be on top. This way we cancel grams and keep the milligrams. Milligrams are an intermediate unit that we don't want to keep in the end. So we will need to cancel those milligrams in the next step. So the second conversion factor should have the milligrams on the bottom. And so the second conversion factor should be 1 tablet over 500 milligrams so that the milligrams cancel and you end up with tablets, which is the desired unit. So if you write down your full calculation, it looks like this. 2 grams of vitamin C times 1,000 milligrams over grams times 1 tablet over 500 milligrams. So we verified that this setup is correct by canceling units. So here we can cancel grams, we can cancel milligrams, and we are left with tablets. So that's the correct way. Next, we need to calculate that in the calculator. So 2 grams times 1,000 divided by 500, right? Remember the 2 grams here is in the numerator. So you multiply it by 1,000 and you divide that by 500. And so that's 2,000 divided by 500, that's 4. So the calculator answer is 4. Now let's see if it should be the final answer. Is the number of sig figs correct? So if we look at the 1 tablet over 500 milligrams, the 1 tablet is obtained by counting the number of tablets. That's an exact number. The 500 milligrams are measured, and here there is only 1 sig fig, because the 2 zeros are not significant because we do not see the decimal point. So 1 sig fig here. 1,000 milligrams over 1 gram, by definitions, those two numbers are exact, so they are not limiting. And then the given amount of 2 gram is only 1 sig fig. So from both the 500 milligrams and the 2 grams, we are limited to 1 sig fig. And 4 tablets, it's already 1 sig fig. So the final answer stays 4 tablets. And so to obtain 2 grams of vitamin C per day, you would take 5 tablets of 500 milligrams each. There's never enough practice with this kind of problem. So here we go, another one. And this one is really contextualized to the, you know, for nursing. So let's look at that text. Children's liquid Tylenol contains 80 milligrams of acetaminophen per tablespoon. If the recommended dosage is 5 milligrams per pound, how many tablespoons are needed for a 35-pound child? Again, I advise you to pause the video, work the problem before you watch the answer, because you're not going to learn how to do it if you're not trying. So here, what is the given amount? The given amount, there's many numbers there, right? There is the 80 milligrams of acetaminophen per tablespoon. So here, keyword, per tablespoon. So you should read this as an equality. You could see that 1 tablespoon, you can make it equal to 80 milligrams of acetaminophen. So that's a conversion factor. That's not a given amount. If the recommended dosage is 5 milligrams per pound, again, we see that keyword per pound. And so you should read that as 1 pound equals 5 milligrams. That's the recommendation. And finally, how many tablespoons are needed for a 35-pound child? So here, 35-pound child is a unit on its own. There is no pair something or contain something. So this should be seen as your given amount. The 35-pound child is your given amount. That's what you start with. It's the patient you have in front of you. It's a 35-pound child. And so the question is asking for how many tablets, tablespoons of acetaminophen you should give. Tablespoons of Tylenol, actually. So tablespoons of 80 milligrams of acetaminophen. So to connect pounds of child to tablespoons of Tylenol, we see here that we have tablespoons of 80 milligrams of acetaminophen. We can see that we have per tablespoon 80 milligrams of acetaminophen. So that's going to be one of the conversion factor. And as I said earlier, the 5 milligrams per pound is going to be another one. So you can see here that in this type of problems, you don't need to look for conversion factors in the tables. It's all in the text. You have to know how to interpret the text. It's very important to take the time to read this carefully and see the keywords like per tablespoon, per pound are keywords that should ring a bell that this means it's an equality. So 1 tablespoon equals 80 milligrams of acetaminophen, and per pound of child, you want to give 5 milligrams. So for 1 pound equals 5 milligrams of acetaminophen. So let's write the roadmap, because it helps to visualize how you will set up your calculation. So we're starting with pound of the person. And then we'll change that to milligrams of acetaminophen according to the proper dosage. And then from milligrams of acetaminophen, we can change that to tablespoon of Tylenol. So from pound to milligrams to tablespoon. So pounds is pound of, weight of a child. Milligrams, it's milligrams of acetaminophen, and tablespoon, it's a tablespoon of the liquid Tylenol. So the given amount is the 35 pound of child. So the first conversion factor will need to cancel the pounds. And so you will use the conversion factor that has the pound, of course, and you will put the 1 pound on the bottom and the 5 milligrams of acetaminophen on top. In the next conversion factor, we want to cancel the milligrams of acetaminophen because that's an intermediate answer that we don't, intermediate unit, I mean, that we do not want to keep. So you will take your 80 milligrams of acetaminophen and put them in the bottom of the conversion factor, and then the 1 tablespoon on top. This way, the milligrams of acetaminophen cancel, and we're left with tablespoon, which is what we want. So when you write down the full calculation, you always want to start with the given amount. The given amount is in the numerator. Remember, the 35 pound could have a line and a 1 under to say that there's nothing in the denominator. Times, multiply by the first conversion factor, 5 milligrams over 1 pound, times the second conversion factor that says 1 tablespoon over 80 milligrams. We verify that this is properly written by cancelling units. If they cancel properly, then we know it's correctly written. Pounds cancel and milligrams of acetaminophen cancel. We're left with tablespoon. So in the calculator, you do 35 times 5 divided by 80, right? Remember, 35 is in the numerator, times 5, and divided by 80 because 80 is in the denominator. The calculator answer is 2.1875 tablespoon. So now let's look at the sig figs. 1 tablespoon over 80 milligrams of acetaminophen. So the 1 tablespoon is counted. That's going to be an exact number, but the 80 milligrams is not exact. So in 80, there is only one significant figure because the 0 is not significant there. So 1 sig fig here. 1 pound per 5 milligrams. They're both measured, but they're both well, the 1 pound can be considered exact, but the 5 milligram is measured. And in any case, they're 1 sig fig or exact. And then the 35 pound, here we have 2 sig figs. 2 sig figs, however, 80 has only 1. So then this time, it's going to be 1 sig fig, and it's not from the given measurement, it's from a given conversion factor. So 1 sig fig. Looking at the final answer, you will keep the 2, and that's it. That's 1 sig fig. What comes after the 2 is a 1. It's below 5, so you will need to round down. And so you will keep the 2 and drop everything that comes after. So the final answer is going to be 2 tablespoons.